Hey guys, it's Mrs. D. I'm just going to go through with you today just about the parts of an atom. We call them subatomic particles because they're part of an atom. So let's just take some time right now. I would advise you to grab your notes and just jot a few things down in your notes. And then I'll have another video of like how to count protons and neutrons and electrons in an atom. So let's get started. First of all, the atom consists of a nucleus made up of protons and neutrons. Protons and neutrons you'll find inside of the nucleus of an atom, and you will find electrons in the space about the nucleus or around the nucleus. And what you'll see in this picture is you'll see this as an electron cloud. And this electron cloud looks very like there's so many electrons, and there's not that many electrons. It's just showing where those electrons have been placed at some point, and it shows how fast that they're moving. Electrons are moving so fast we can't even imagine how fast they're moving because they're creating a space we're not able to even like get through. They're creating a solid that they're moving that fast. So the nucleus again is at the center, and that's where you're going to find the mass and the most density at the center of an atom. Now the size of an atom is wild to think about. So the size of an atom is 100 picometers across, and a picometer is a trillionth of a meter. So pretend we took a meter stick and we cut it into a trillion pieces, and then we counted off like 100 of those. We still wouldn't be able to even see what we could find. You cannot see an atom with the naked eye, and you can only see an atom with a specialized microscope called an electron microscope. You can't see them with the microscopes used in biology. An atom is 1 million times smaller than the width of human hair. So if you pluck a piece of hair from your head and you look at the width of it, an atom's going to be 1 million times smaller than that even. If you placed a dot on your paper, about 5 million hydrogen atoms could fit in the space of that dot. Now, obviously, hydrogen atoms are the smallest atom, but still, you would be able to put like nearly 500 million atoms of any other atom. This atom consists of subatomic particles, and like I said, subatomic means part of the atom. Sub means under or part of the atom. So we have a proton, we have a neutron, and we have an electron. And you can see the notation for that. Protons can be written as a little p with a plus sign as its superscript. Neutrons as a little n with a 0 as its superscript, and electrons as a little e with a negative as a superscript. Now, inside the nucleus, that's where you're going to find protons and neutrons, but electrons are in orbitals outside of the nucleus, and we'll learn more about those orbitals as time goes on. The charge of a proton is positive, the charge of a neutron is neutral, meaning it does not have a charge, and the charge of electron is negative. Now, the size of subatomic particles, you guys do not need to know the actual mass of these subatomic particles whatsoever, but what I want you to see in particular is I want you to see that the mass of a proton or a neutron is over 1,800 times the mass of an electron. Electrons are so tiny that we don't even need to worry about the mass of electrons because they're that small. We don't add them in if we're kind of like trying to find an atomic mass or a mass number. Electron mass is just negligible because it's that tiny. The atom is mostly empty space. And so if you think about this, if you have a nucleus that's the size of a marble, just a little marble, and say the electron would be the size of a grain of sand, there would be about 1/4 of a mile to scale in between the nucleus and the electron. So really an atom is made mostly of empty space. And it's important because empty space creates some like magnetic and electric fields. And so without the empty space, what would happen is these nuclei that are positively charged because they have protons inside of them would be like reckless and would fuse so much faster to other atoms because there's nothing in between. There's no space for these to move. There's no space for the electrons to move. And it would just be like chaos. We wouldn't have any reactions of any kind. So empty space is so important inside of the atom. If you think about this and you took out all of the empty space that was and every single human being on this planet. And you guys, the global population now is around 7 billion. The entire global population could fit inside of an apple if you took out the empty space from every atom that made up every molecule that made up a human body and all of the humans on the planet. That is wild to think about how much empty space there is. The next part is the next video I want you to watch. We're going to count the pieces. So I'm going to show you how to determine how many protons, how many electrons, how many neutrons are in an atom.